Good evening, students. Today's question from May 20, 2024, and this question is belongs to thermodynamics. So now coming to the question, the volume of ideal gas contracts from 10 liters to 2 liters. Means initial volume 10 liters are there. That gas is contract to final volume how much? That is 2 liters. So initial volume 10 liters of gas is there. After contraction, this is coming to the 2 liters. When applying under an applied pressure, so pressure how much they are applying? 2 atmosphere pressure. So when 2 atmosphere pressure is applied on the gas, 10 liters of gas contracted to 2 liters. Next, during contraction, the system evolved, means the system is released 900 joules of heat. So heat is represented by Q, that is heat released by the system. So negative sign, heat absorbed by the system, that is the positive sign, and heat released by the system, that is the negative sign. Here during contraction the system is evolved means released only. So how much energy is released? 900 joules of heat is released. So that's why released means we have to keep the negative, and this is the 900 joules they given. Next, the change in internal energy they are asking. So delta U they are asking. So this is the information from the question. Now first of all calculate the work done. So W equal to minus P external into delta V, minus P external into delta V, minus how much pressure applied? 2 into delta V. Delta V means that is the V2 minus V1. So minus 2 into, this is P external, that is the units are atmosphere and volume is in liters. So V2 minus V1, V2 is the 2 minus 10, then that is the minus 8 into atmosphere liter. Now minus into minus plus, so totally that is the 16 liters atmosphere this is. But the given heat in the joules, so this one we have to convert it into the joules only. So now 1 liter atmosphere equal to nearly 100 joules, 101.3 joules, this is the value. 1 liter atmosphere equal to 101.3. So now 16 into 1 liter atmosphere, how many joules? That is the 101.3 joules. So now 16 threes are 48, 4, 16 ones 20, next 16 ones 16. So this is 1620.8 joules. So this is the work done. Now they are asking delta U. Already we know, according to first law of thermodynamics, delta U equal to Q plus W. Delta U equal to Q plus W. Q how much? Q, that is the released energy. So that's why minus 900 joules plus W is the 1620.8 joules. So this is minus 900, this is the plus 1620.8 joules. Then 1620.8 minus 900, then we are getting the 720.8 joules. So this is the internal energy change in the joules. So this is first, they given the initial volume and final volume, and pressure also are they given, and heat is also heat evolved by the system they given. So heat released by the system, so we have to keep the negative sign, and then they are asking the delta U. So first delta U equal to formula Q plus W. Q we know, but we don't know the W, so calculate the W. W equal to formula minus P external into delta V. P external how much they are applied? 2, and delta V means V2 minus V1. V2 how much? That is the 2, and means V2 means final volume, V1 is the initial volume. So 2 minus 10, that is the minus 8. So minus 8 into minus 2, that is the 16 liter atmosphere. So heat they given in the joules. So that's why work is also converted into the joules. 1 liter atmosphere equal to 101.3 joules. So 16 liter atmosphere equal to 16 into 101.3 joules, that is nearly 1620.8 joules. So this is the work done. So Q value we know and the work also we know. So calculate the delta U according to first law of thermodynamics. So delta U equal to Q plus W, substitute on that. Then delta U equal to 720.8 joules Kim. This is the answer for this question. Thank you.